Hello, this is Ram Mohan. I am working as head of the department for Electronics and Communications Engineering section. I am currently placed at Government Polytechnic, Mahabubnagar. The subject I will be dealing with is the basic electrical and electronics engineering. The topic is resistors. The subtopic for the current session of discussion is the resistors connected in parallel, calculating its R equivalent and some problems on that. The objectives for the next session will be as follows. Upon the completion of this session, you would be able to derive an expression or an equation for the equivalent resistance of resistors connected in parallel, and also calculate the equivalent resistance of resistors connected in parallel. Okay, they look same, but first one is the derivation and the second object is to calculate in some problems, in some circuits where it is connected in parallel. Now let us recap what we have learned till now, because this is connected to some resistors. Let us see what we have to do with that. What is resistance? What is resistance? It is the property of the material to oppose the flow of electric current to pass through it. Okay. So when current you are applying or attempting to pass through a conductor or any material, it is its property to oppose that. Yes. See, this is a phenomenon of that. You can see that arrow is showing that there is no resistor connected in the line. So what you are seeing is a line, and you can see the current, that is a notation of a current, and it is flowing from one end to other end, and the size of that is trying to tell us the amount of current that is flowing through that. So it is more. Now let us see what happens if there is a resistor. Yes, so here in the same line you have connected one resistor which is being pointed out by the arrow. So what happened to that guy? So that is amount of current, it has absolutely come down. So small, when there is a resistor, small flow of current is taking place. Yes. So this is the denotation of the property of resistance. So as per our definition, what is it? It is a property of the material to oppose the flow of electric current. So flow of electric current is nothing but flow of electrons to pass through it. So here you can see there is a voltage applied and there are few bunch of electrons, and you have a resistance denoted by a hand. So it is trying to actually push or oppose the flow of current or the electrons. You can see there on the left side you have a large current that is entering into that material, and at the right side end you have a small current coming out, and this is happening just because of the property of resistance. So let us recap further and see what we have learned till now. So here we are trying to see the most conductive elements that are available. So the materials are in the highest priority of conductivity. So top one is the silver, and here also we have underlined it there on the left side. So it is silver, which is the best conductive element. Next comes copper, and then it is gold, then aluminum, beryllium, calcium, magnesium, rhodium, and there actually you can also see its atomic number along with the material being on the display left side. You can see the atomic number of that as well. So rhodium, and then sodium, then iridium. Sodium, iridium. Yes. So the best one is silver because it is little costly, or it is cheaper than gold, you can say. And copper. Next comes aluminum. Right, so in the market we see nowadays mostly copper is used, but it has been dominated by aluminum in the very recent past. Now let us see what is a resistor. So here a resistor is a passive component which opposes the flow of current. So what I have discussed, it was the property of resistance, and this is resistor. So it is a passive element. Let us see further. So this is its property which is exhibiting the resistance, and it has to be replaced with a component, an electronic component. So it is this. So this is a type of resistor which actually performs or shows off with the property of resistance. So here you can see the resistors. So these are different types of resistors that are available in the market, I should say. Yeah. Then what is the equivalent resistance when two resistors are connected in series? The value of each resistor is 1 kilo ohm, the other one is 560 ohms. So how much it should be? So it should be 1560 ohms or 1.56 K. Then what is the equivalent resistance when 5 resistors each of R ohms are connected in series? That in series, how much it should be? It should be 5R. Now coming back to our topic, it is the resistors in parallel. So series we have already learned. Once again, just recap. So when they are connected like this, one end is connected to the other end, so that is called end-to-end connection, and they are in series. Resistors are said to be connected in series when they are connected end to end, as shown in the above figure. So that is called a series connection. Now the total equivalent resistance of the combination is expressed by the following equation, that is R equivalent or R equal to R1 plus R2 plus R3. So this is what happens in a resistors when they are connected in series in a circuit. So suppose 5 milliamps of current is allowed to pass, and here the current remains same in the whole path. We have to remember that in series connection or a circuit, the current remains same in all the resistors wherever this current is flowing. Points to remember. Now let us see about the parallel connections. So like this in the figure, when you see that they are connected like that, one is tied to the other and likewise. So this connection is called as a parallel connection of resistors. So when they are joined in the figure as shown in the figure, then they are said to be connected in parallel. So the parallel connection, let us read out that statement. In parallel connection, the voltage remains constant. What happens in series? It is current that remains constant. Here it is the voltage that remains constant. And in parallel connections, the total current adds up. That we should remember. So above there is a expression for equivalent. Well, we'll see further. Then we'll also derive that particular equation. So this is the resistors in parallel connection. So you can say current I is flowing into the node where it is dividing into current I1, that is through resistor R1, and similarly current I2 that is flowing through R2, and current I3 which is flowing through R3. So the current total I is splitting or getting distributed among I1, I2 and I3 based upon the resistance value in each arm. So this is a phenomenon of parallel resistors. Let us assume that there is one source and you have two resistors each of 400 ohms connected in parallel. Then by simple equation, like the current will be calculated as 5 milliamps, and that 5 milliamps has to be divided into two arms, two paths rather, two circuits, because there are two resistors. So it is equally distributed among the two. That is because both of them have same value, which is 400 ohms. 400 ohms each. So 2.5 milliamps is distributed in each arm. Now, when the resistors are connected in parallel, the potential difference across each resistor is same. Then current in each resistor is different and is given by the Ohm's law. So it is the voltage. So voltage divided by R will be giving the current in that particular path or in that particular resistance. And then coming back to calculation of the total current, it is the sum of three branch currents. Three branch currents. So in parallel connection, the voltage remains constant across each resistor, whereas the current adds up. So the total current is equal to the sum of current flowing in each branch. So this is supposed to be the parallel connection, and here we see the current I is coming out from the voltage source battery V, and this current is again dividing into three currents, that is I1 in I through R1, then I2 is the current that is flowing through R2, and hence the next one is the current I3 that is flowing through R3. So this is a phenomenon which is shown here. So a current of 5 milliamps is flowing from the source into the parallel resistor network of 400 ohms each. So here we see that they are equal value. That means the current that is coming from the source will be equally distributed into two paths. So how much current should be there? It is 2.5 milliamps as shown there. So the current 5 milliamps from the source is branching out into two resistors, and that is 2.5 milliamps that is flowing in each R. So let us see about the resistors connected in parallel. So when they are connected in parallel, the potential difference across each resistor is same, and the current in each resistor is actually calculated is different, and it will be given by the Ohm's law. So it is simple, I equal to V by R, and then the total current, that is the sum of three branch currents, that is I1, I2 and I3. Then let us now derive the equivalent resistance of the resistors which are connected in parallel. So we are looking into derivation of the equation for equivalent resistance. So consider the three resistors R1, R2, R3, and they are connected parallelly across a battery of V volts. And the total current I divides into three parts, I1, I2 and I3. So the voltage across each resistor is same. So therefore, and next, by applying Ohm's law, the current flowing through each resistor is given by I1, that is equal to V by R1, and I2 is equal to V by R2, then I3 is equal to V by R3. So this is how we are able to calculate the value of current in each arm. Then would we understand that for the total current to be, so the total current is equal to I1 plus I2 plus I3. So it is the sum of all the three currents flowing in each resistor. And what is I1? So I1 is equal to V by R1. Similarly, I2 is equal to V by R2. Then I3 is equal to V by R3. Now by taking this V as common, so you will be getting 1 by R1 plus 1 by R2 plus 1 by R3, that is equal to the total current. So if you transfer this V onto left side, then it will be I by V, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3, and 1 by I by V is the V by I is nothing but resistance of equivalent of the whole network. So that I by V is the total resistance of equivalent, but it is given by I by V, whereas for R it is V by I. So if you inverse that, you will be getting the value of resistors equivalent to the parallel network. Therefore I by V is equal to 1 by R, and so 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If suppose there are suppose if there are n number of resistors, they are connected parallel, then the equivalent resistance 1 by R will be equal to 1 by R1 plus 1 by R2 plus 1 by R3, so on for 1 by Rn. solve a problem. So there are three resistors. One is 10 ohms, the other one 15 ohms, and the other 20 ohms, which are connected in parallel. Then what is the equivalent resistance? So let us see the solution. For that, the given data is R110, R215, and R3 is 20 ohms. Then you have the network, that is parallel network as you have seen in the figure. Then coming back to calculation part of the equivalent resistance, it is 1 by R, and that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So substituting the value for R1, it is 10, so it is 1 by 10, 1 by 15 plus 1 by 20 ohms. So here 1 by R is equal to doing some common LCM, and then you get it as 13 by 60. So further getting into the numerical value, so 1 by R is equal to 13 by 60, and therefore R will be equal to 60 by 30, which comes to value of 4.6 ohms. So the equivalent resistance of the circuit R is equal to 4.6 ohms. Now let us see a problem 2. Now let us see what the problem is. So here there are three resistors, 3 ohms, 2 ohms and 5 ohms, which are connected in parallel, and here the data given is they are connected across a battery of 20 volts DC supply. Now find the current in all the three branches of the parallel circuit and the total current of the circuit. Let us see. So this is circuit we are taking, and we have written the given data, that is 3, 2 and 5 ohms, battery is 20 volts, and then coming to solution. So the given data, let us note down on the left side. So the given data is R13, R2 2 ohms, then R3 is 5 volts. The voltage of the battery is 20 volts. And what we have to calculate? We have to calculate the current I1, I2, so our task is to find out current I1, total current I, current through R1, that is I1, I2 current and I3 current. And then the equivalent resistance is equal to how much? It is R. So that is equal to, you substitute this into this equation, you will be getting R equivalent is equal to 3 into 2 into 5 by R1 R2 plus R2 R3 plus R3 R1. So we will be getting a value of R equal to 30 by 31, that is 0.98 ohms. So the total current in the circuit I is equal to V by R. So V is 20, R is 0.9, so that comes to about 20.4 amperes. So this is the total current I. Now the branch currents I1 is equal to V by R1, that is 20 divided by 3, so you get 6.66 amps. Similarly 6.66, similarly it is equal to 20 divided by 2 ohms, so this comes to 10 amperes. And similarly current I3 is equal to V by R3, that is 20 by 5 ohms, so that gives us a value of 4 amps. So these are the three values that we need to calculate as per the question or the problem asked for. Now let us summarize what we have learned about the resistors, or in the discussion previously done. So if there are n number of resistors, that are connected in parallel, then the equivalent resistance 1 by R is equal to 1 by R1 plus 1 by R2, so on till 1 by Rn. So this is what we have seen, and we have worked out some problems. Let us see some quiz. When there are two resistors R1 and R2 connected in parallel, the equivalent resistance of the circuit is given by choice A R1 R2 by R1 plus R2, then choice 2 R1 and R2, choice C it is R1 plus R2 by R1 into R2, then D is R1 plus R2. What is the right answer? The right answer is option A. Let us see next one. When two resistors 5 ohms and 10 ohms are connected in parallel, what is the equivalent resistance? It should be very easy for us to calculate. The choice given is 15 ohms, 3.33 ohms, 50 ohms and 0.33 ohms. What is the right answer? So it is 3.33 ohms. Right. Now let us see further quiz. If 2 and 30 ohms resistors are connected in parallel across a battery source of 100 volts, then what is the current through 20 ohm resistor? It should be simple. Let us see what you have to say. Choice A. So we are being asked about the current flowing through the 20 ohm resistor. Choice A is 5 amperes. Then choice B is 3 amperes. Then it is 2 amperes. Then D is none of the above. So what is the right answer? Right answer is choice A, that is 5. It is simple. 100 volts divided by 20 ohms. 5. That's it. Next one. If 30 and 60 ohm resistors are connected in parallel across a 200 volts supply, then what is the total circuit current? So here they are asking about the total circuit current, that we should remember. Yes, what are the choices? Let us see. Choice A is 10 amperes, choice B is 9.98 amps, choice C is 11.5 amps, then choice D is 10.5 amps. The right answer should be how much? 60 and 30, so 30 into 60 by 30 plus 60, it is 180 by 90, so that will be how much? 20 will be 10, so the right answer should be 10 amperes. Now let us see some frequently asked questions in the topics we have just now covered. So derive an expression for equivalent resistance when 3 resistors are connected in parallel. Then 3 resistors of 10 ohm, 15 ohm and 20 ohms are connected in parallel across a power supply of 220 volts. Calculate the equivalent resistance of the circuit, then the current through each resistor, then the current that is total current of the circuit. So I think that should be easy, and here I am giving you the answers for a quick confirmation. Okay, then thank you very much. Let us conclude here with this session. Thank you all.